Recorded.
So hey everybody, so this is the official of the Seattle Web Components meetup. If anybody is ever interested in going to San Francisco, Web Components meetup is actually happening down in San Francisco. Huge plug because it's kind of a big deal. It's actually being run by the guys who are pretty all of the things that I'll be talking about tonight, because it's the meetup is actually being managed by one guy in particular named Justin Fignati. So if you're interested in web components and you want to learn more about web components, follow Justin Fignati on Twitter or however you want to. I mean, how to spell his last name, but if you look up the lit element project in GitHub, his name is all over it because he's pretty much the primary to it. But Justin, just kind of like a quick story about him is that he has been working with the Polymer team for Google, really kind of shaping on how all of this stuff is moving forward. And then when the opportunity to create a couple of libraries, of which I'm going to be giving demos of later in this deck, lit element and lit HTML, he pretty much is the senior developer behind those things. So he's a major thought leader in this space. He's a major thought leader within Google around web Polymer project forward. But anyway, we're going to talk about a little bit more about that later. But coming up, I believe it's the day after the Super Bowl, is they're having the second web components meetup down in San Francisco at Google Labs. I'm going to try to be down there. Like hundreds of people show up to that one, but still only like this many people actually understand what's happening. It's kind of funny, but everybody shows up for meetups in San Francisco. Like it doesn't matter. It's like, yeah, it's just like I'm gonna have a meetup about aluminum cans, and like everybody will show up. Right? That's just how they do that. I want to say a special thanks to Code Fellows for allowing us to use their space. It's super awesome. This is a pretty cool space. And if you have any questions about Code Fellows itself, you could ask me or I can point you. I used to teach here, so I have a history with Code Fellows. Super cool place. Really love it. This is legal. My opinions expressed are my own and not specifically the opinions of my employer. So if I say anything bad tonight, it's not Alaska's fault. Speaking of opinions, so opinions are absolutely everywhere. So no matter what you're doing in life, whether designer, engineer, woodworker, steelworker, I don't care. Everybody has opinions about everything that you do. And in the web space, the thing that I've always found super is that these frameworks have opinions about standards. Okay, so since the dawn of the web, we've had shortly thereafter JavaScript, but nonetheless, how these three things are used in concert within these given frameworks is the opinion of one of these frameworks has a different opinion about how these three things should be working, reacts so much that they invented their own version of HTML. So moving forward, though, the thing that's interesting to me about opinions is that strong opinions lead to standards, right? And again, so taking a step back and then again saying standards are everywhere, been kind of really interesting to watch in the evolution of web components, because I've been following web components since the standard was defined nearly 13 years. And the real trick behind web components and standards over this period of time is how do we actually do it, right? So again, kind of talking about the Polymer team at Google and Justin, the thing that they really brought to the table that was interesting and instantly hated is that when they invented Polymer, they started formulating an opinion about how we should use HTML, CSS, and JavaScript in order to meet of building web components, of which then also turned into a framework, which then also started formulating more opinions. So over that period of time, because Polymer, I think that was maybe like 6 years ago when Polymer 1 came out, and hated because it was really hard to do. Nobody saw the value in it, and it had a lot of downsides. And the one major downside was that none of the supported anything that they were coming up with. So then you had like this massive polyfill to get the browser to do anything. So there's only like a small handful of companies that kind of like off the ledge, and they, there was like the guy that spoke at the last meetup. Their company just really kind of jumped in and said, we're going to start building things with web components because there is a certain brings, even though the engineering is hard. So we're going to bet on that horse and see what happens. So if you were a betting person and you were looking for a short, quick payout, web components was then companies like the gentleman I'm talking about, it really started to pay off over time because now these guys again have their leaps and bounds ahead of everybody else as far as how web components work, how to build them, how to ship them, and what works and what doesn't work. So they thought leaders in my opinion. So anyway, and what's also interesting, and you'll start seeing in the code examples that I show later, is that even that whole cycle of standards being, opinions about standards creating frameworks, that continues to play a full cycle. And the things that are becoming standardized, again, are even kind of coming from other frameworks. So there's a lot of things that are just kind of like merging, which is super interesting to see. And from an engineering perspective, I'm super excited about that. New ideas being brought to the market that people can use, and they're not wildly different. Because like when Polymer 1 came out, everybody's like, oh my god, that is so different, so scary, so hard. I don't at a point where it's not like that anymore. So the next interesting thing is design systems. You can have an even longer conversation about opinions versus standards when it comes to design system, because every design system has a very strong opinion. So when I took the position that I have at Alaska to basically be the tip of the spear, finally delivering a design system for that organization, it was a conversation that I had with my manager and director, and they said, what design system are we going to follow? And I said, not, because all of them have such varying degrees of opinions on how something can be done. To follow one person and say that we're going to repeat everything is stupid. So, there's what I can say to anybody who's starting a design system and looking at previous design systems is, without it, I mean, look at what they did, see what their successes are, see what their failures are, formulate your own opinion and move forward, because there's nothing in this space that I feel is honestly concrete enough to be called a standard by any stretch of the. So getting into these guys, I mean, now, we live in a world of frameworks. So this again was another problem that I was kind of thrown when job, because they're like, okay, so you have to deliver on the design system. What framework are you going to choose? I'm like, I'm not going to freaking pick any one of these, because the problem that I have is that I have a team. I have one team in Alaska that's using every one of these things. I have a React team, a Vue team, an Angular team, a Svelte team. It's like the Angular components, and then they're playing with Stencil, and it's just like everybody's playing with everything. And there were a lot of people, well, we should just pick one. And I'm like, but I don't think that's a good idea either, because now you're losing a lot of value of learning from these different frameworks and these different varying opinions. What we need to do is look on one thing that can be delivered. So 15 months ago, I took a job and I made a huge bet, and I said, going to start looking at web components. And there's a project that GE did called Predex. Anybody ever? So Predix was a huge development environment for GE, and it was their whole app environment. And then there was a team that was the Predix design system team. And this was the first team that I was ever aware of, and they kind of made waves in the industry that they built the first design system using pure web components, and they had full support for React and Angular at the same time. So this was the first engineer deliverable on a huge scale, an enterprise scale that I've ever seen that made that promise. The only thing that killed them is that, you know, when you're super bleeding edge, that you're bound to like make mistakes, and it gets a little hard to manage. And they built the whole thing on Polymer 2, and there was just a lot of problems. Environment, it wasn't as forthcoming as if you were to do something today. So, but that project proved to the world that you could do that. You could build a universal CSS and JavaScript in the web component spec using Polymer and deliver to multiple engineering teams. Fast forward today, that's even easier, and there's more, you know, vast. So, so just quick, my name's Dale. If you haven't figured that out yet, maybe. Another UI guy on Twitter, if you care to. I'm not totally bombastic. I work for Alaska Airlines, and my whole thing right now is web components. My life, my career, my job, my daily, everything I'm doing right now is 100% focused on working with and delivering web components for Alaska Airlines and all of our properties and all of our projects. So, to this, right? So, no matter what you're doing in any organization, this is your problem statement. How those two communicate, how those two groups deliver assets to each other is a ongoing battle since I began my career close to 20. Okay. And before there was design systems, there were pattern libraries, you know, we did all these things. Pattern libraries since 2008. You know, it's not a new idea. The concept of design systems kind of caught fire years ago when you know, Lightning Design System was put out there, and Gina really kind of set everything on fire from that perspective. But then again, you know, it exploded. Right now, you know, there's all systems that are out there, and there's continuing to be more and more and more. Like Adobe just released one, and everybody's coming with another one every day. Okay, fine, like just run with it, go. I don't care. The thing that everybody's trying to do is they're trying to drive consistency. I'm 100% on board with that. But the thing that I've been speaking about of years is like, how are you driving consistency? Like Lightning Design, I mean, they really broke a lot of barriers with what they built, and there was a lot of interesting ideas there. But then it was a copy and paste type scenario. There's this one giant style sheet, and then there's these models of HTML, and my battery's about to die. Crap. Nope. Where'd my bag go? Sorry. Should have done this before. Yeah. I just have to plug it in. So anyway, I'll keep talking while I do this. So the big thing, like I said, was that like consistency, because just by doing copying and pasting across the board, you're allowing a lot of opportunity. And it's great that you have like this one website and it shows how everything's going to get done, but multiple points of failure, which I can kind of get to in a minute. So forward, again, you have the design and code problem. So just for the sake of argument, we'll say everybody's using Sketch, whatever, if you're using Figma, I don't care. But nonetheless, I mean, there's decisions doing that kind of stuff there. So the HTML and SAS that so many of those other design systems use, Lightning Design used it. Web Foundation project I worked on at Microsoft used it. It's, you know, there's a lot of places that did it, but there was epic amounts of failure. And the reason for is basically right here. Is if you're going to try to dictate a design system and then you're going to say like, here's my HTML model and then here's a style that you should follow, those two are always going to be out of sync, and you're basically kind of demanding that there is a human being who's going to maintain the contract between those two things. Right? Is if the HTML gets updated, somebody has to get triggered on that engineering team to go and update their HTML model however they integrate it into their application and hope to God things still work. And then the CSS is usually so rigorous that it's like once you start moving things out of position, it just never works. So again, it brings me to the next point, contracts will be broken. CSS, you have to make sure that you're using those two things in concert, otherwise they don't work. So then everybody says CSS naming conventions. Those are also doomed to fail because I've yet to see a project in my entire life where everybody is using a naming convention consistently. Because unless there's one person who's watching every pull request that every engineer does, whoever writes any ever line of code, you're not going to maintain a naming convention that ever is worth a damn. Okay? It's just not going to work. So, and then this is kind of like my favorite statement, but the devs will make things. Okay? Which leads to this. Is the designer is kind of creating a thing, and then the designer is consuming that thing and making their version of a thing. But then the engineer has other things to worry about than if you change your design thing. And so then the updates never happen. So then everybody need to go down a certain way, and there's constant battles, if you will. So kind of digging into that a little bit further, is like this is a really really bad idea to me, and I've said this for a long time for the specific reasons is that not everyone uses your framework, right? So I was telling a story earlier about a developer that I met, and she was telling me that like their whole company bet on Angular, 100%, heads down into Angular. They used Angular 1, they moved up to Angular 2. They're going through all the things. They built the whole design system in Angular. It was a small company out of Minneapolis. Somebody from NBC came in and said, "What the hell is all this Angular stuff? We use React." So like everything that they were doing was instantly broken just because of a management change. Right? And so now they had to figure out on how to migrate all of this wonderful UI from their application that NBC just bought to get it into NBC ecosystem with whatever team that they were working with and convert all that stuff over to React. They didn't have any React engineers. It's just like it's problem on top of problem, and everything has to get redone. Right? So that's just like an epic amount of work for absolutely no reason whatsoever other than somebody's opinion about what framework to use. Right? Instant failure. Forever. I was a Ruby on Rails engineer. I was convinced that Ruby on Rails was going to rule the world forever. Hands on anybody here who codes anything Ruby on Rails? Yeah. Right? How many jobs are out there for Rails devs? Right. So it's everybody's in this new wave of React right now. Give it a couple of years, React will be dead. React's going to get replaced by something else. Svelte is coming right behind it at heels. There's a lot of people very excited about even lighter frameworks because we don't need things to be as big. And this is also kind of a big one too. There's not a single one of those other CSS problem. Okay. Anybody here tell me what the CSS problem is? What's that? Did you say the cascade? The cascading. Yes. CSS is global. Okay. Everybody writes really shitty CSS. So when you inject more CSS to change the design, you write more shitty CSS, and then it's all cascading down, and then everybody talks about how much they hate CSS, right? All of those other frameworks, Vue, React, has ever come up with a good reason or a good way to solve the CSS problem. Like React, basically, they kind of invented CSS and JavaScript, but that's masking the problem. That is not an honest to God solution. It's a nightmare solution if you really ask me. I got on board with it for a little while. I saw some promise, and then I quickly jumped off the boat and set it on fire. This is another big one too. Is every engineer that I talk to now, and I interviewed every engineer the last times. I was like, I need to deliver a design system. And they're like, if you make a giant framework that I have to get my head wrapped around, I will set you on fire. Right? Nobody wants that because they're already dealing with the other thing that they have to do. Right? They built a whole application in React. They just want a UI that works. How do we make that as easy as possible without having to have massive configurations and setup processes and all that kind of shit? Just give me a freaking UI that I can use. My React framework will live forever. It's beautiful. It's magical. And then the team shows up and they say they want to use Vue. And the first thing you got to say is, well, you can't use the design system. And they say, I don't care. Now your design director's mad. The whole promise of the design system and consistency is mad. Everybody's mad, right? Because the wrong thing is dictated from the wrong perspective. So this is how I see the world work, right? And this is how I've seen the world work for a long time. So you have the design side, and they come up with design patterns, widgets, blueprints, whatever you want to call it. And then you have your React team and your Angular team. And so each one of those things, React team coded those two widgets, and then the Angular team coded those two widgets. Okay, that's great. Let's fast forward a little bit, and now I have 5 widgets, but 4, and the Angular team did 3. Right? So the thing that's really important to get here is that the design team has an intent of giving to your customers. Who's failing in this scenario? Who's getting the shit end of the stick? Customers, right? Because the engineers will never pace of what the design team is doing, ever. So you move forward a little bit, and then the second widget has a version 2, and then the React team was, but Angular is still using version 1. So why is it fair to your customers that whatever experience that they're doing, if they go to one part of the application, they get something cool. If they go to another part, something old, right? We experience that all the time with every application we ever use, unless it's a small startup with 8 people in San Francisco, and it has 1 page. As soon as you get bigger than that, this starts happening all over the place. Fast forward a little bit more, you get more widgets, you have less engineering. Go a little bit more, now we have more things, different version, everybody's having a different experience. Your customers are, not really, customers who are paying attention will notice this, and they will see the cracks. Then your Vue team shows up. Right? You can't stop this from happening. Right? This is going, if this is your model of working, this is exactly how it works. So, of course, I'm going to say yes to web components because that's the point of this talk. So, the reason I say it is because encapsulated CSS, it's done. From the dawn of inventing web components, one of the main things that was always in the specification was that CSS was going to be encapsulated within the scope of the component, right? That's paramount, and that was one of the hardest problems to solve on how. So this is a huge, huge part of web components, and whenever you hear people talking about web components, they're like, oh, it's so hard, we just use the low. If you're using light DOM web components, you're pretty much kind of just giving up on life because you're not getting any of the benefits of using a web component because you've just now thrown yourself into the whole open space. Same thing with JavaScript. You write features and functionality inside the scope of the component. You deliver the component. That's exactly how you engineered it in that space. There's no conflict between anything outside of it, right? So if you want anything to have a specific action, you can be guaranteed that action is always going to happen when you ship it inside the scope of that component. Same thing with the user experience. Depending on the size of the component that you want to create, when everything goes with it, and it's guaranteed to work it's kind of like little mini Dockers, right? It's going to work as you engineered it when you put it out there. So I have a poster at my desk, pretty simple. What happens in the shadowDOM stays in the shadowDOM. It's really the answer to all of the problems that we've had as web developers since we've started building websites. All like JavaScript engineers have been coming up with like a number of different ways to basically wrap functions or namespace things, and how do we keep things out of the global and different tricks and hacks in order to kind of keep things centralized. Web components is the honest to God answer without doing any of that stuff. So what's really cool about it is that we have the tech today, which we didn't have a number of years ago, is that you can create every component, you can package it, and you can deliver it independently. So everything can have its own version history, everything, it's however you want to build it with individual repos or mono repos, I don't care. But at the end of the day, you can deliver individual either via NPMs or CDNs, and then everybody else can just consume it with the assurance that what they get and they put in their project is going to work as is. So import the project, profit. So at the end of the day, everybody starts getting a little happier, right? But most engineers, when you're like, oh no, you don't, you're like, I hate you now. It's like, I've dedicated my life to this tool and you're telling me that I don't need it anymore. So let's look at where components is part of your development pipeline. So you have two design things of which are turned directly into web components. Then you have your React project and your Angular project that are web components. You're done. That's it. The React team and the Angular team didn't have to do anything special other than consume the component that you built or that they built. I don't care who built it. The engineer, I don't care who builds it, but the spec is that you're building a component. Your Vue team shows up, nobody cares, right? They consume the exact same thing. Everybody has the ability to do whatever they want, but the UI is not the problem that it used to be anymore. Nobody has to redevelop anything. You just ship. This is my favorite part because I do this to people all the time now, is that the design team comes up with an alteration. Cool. So I make the version, ship the component, and then when the engineering teams basically run the next update, run the next build, or if it's out to a CDN, they instantly get the new thing, and they didn't have to do anything. Right? They just get all this GUI goodness instantly for just playing along. Right? So now your question is going to be, well, there's a wonderful website called Custom Elements Everywhere because you can use them everywhere. So 100% even Angular 1. If your team is doing an Angular 1, I've actually heard this story a lot, where teams are supporting Angular 1 projects and they hate their lives. So they actually start redoing components so that it's actually something new and interesting and they don't have to deal with all of the other BS that Angular 1 is forcing them to do. Dojo works with web components. Basically, if it's like standard HTML and JavaScript, you're going to support web components, of which Preact is not. And it's little. So, but what's happening here? Okay, why do we get like this little bit of sadness? Everything in web components still works with React. The problem that we have is that there's the easiest way I can describe it is that JSX is not HTML. Okay. If you understand that, you understand where the problem is with React and web components, because web components is 100% following the HTML specification. When you have an on-click equals that works inside of HTML, try to do that crap inside of React and it blows up on you. Right? So the issue that's outlined here is that they do work, but it depends on the type of data that you're going to pass into the component. So the more complicated the component becomes, the more you have to figure slightly different way of getting React to pass that data into the component so that it will the two things will work together. The good news is that the React community, this is their fault, right? And there's been a lot of noise and chatter in all of the React meetups in Seattle and San Francisco and everywhere else in the country. The React team has responded very positively, and they said with the next major release of React, they're going to be 100% here because they're going to fix their mess. Okay, so this is the trend that's happening. Is that like web components has been a promise for a long time, People have been dragging their feet on it because they're like, browsers don't, frameworks don't support it. Browsers support it now, and I'm going to get to that. So what about browsers? Hooray! Every major browser 100% supports web components. Okay, so there's literally very few things stopping you from in your projects. Okay, if you're building like a browser, for instance, so you're not really overly concerned about environment, so you can use web components. And there actually, if you don't know, there's a lot of companies that are doing that. And I'll kind of here. So who is already betting on web components? Little startup in Redmond, 10,000 person shop. They're components. They're delivering frameworks basically every day. There's so much stuff that I'm seeing going out ever since this project's been released that they're really picking up the ball and saying, shipping everything web components. The thing that's going to stop you, and this is legit, is if you have like a large part of your revenue equated browser user base. So, which kind of gets into the interesting conversation of there's literally three ways to build. Is you build it using the standard version 1.0 specification that the browsers all understand, which you can, but it's a lot of JavaScript and it's kind of gross and painful. Okay. Two, you can use what are basically called web component preprocessors. Now, there's two companies that are really on that. One is Salesforce, and the other one is the Stencil.js from Ionic. That's what it is. What these guys are doing is that they just basically created a different DSL developing domain-specific language development code, and then it runs through a machine, and it on the other end comes out terrible code. Okay, but it's the terrible code that the browser understands, right? So they're going to vary depending on how you want to use that. So a lot of companies that use Stencil, I mean, they have their different opinions on why they want to do that. I'm totally fine with it. It's not a product that I feel I need to use. Of course, if you look at any of the stuff that Salesforce is doing, is because they took the Lightning design system and they created Lightning Web Components. And so when I was at the meetup at Salesforce was talking, he basically said on how more than 50% of their revenue is coming from users on Internet Explorer. Right? Yeah, it's like this massive number of Internet Explorer users. So they wanted to use web components, so they basically came up with like amazing technology, basically shoehorn web components into the older versions of Internet Explorer. And the kind of the cool thing is that they're being super public about everything that they did. The that they came up with to get, like, I think they even run their stuff on IE8. How they got that to work is all going to, if it's not open source now, it's going to be open pretty soon. So they're being super open about it. But nonetheless, I mean, it's like everybody's making major bets on this. So, you can legitimately ask yourself, like, if my company's not using web components today, why not? Because in 5 years, you're going to be like, we missed the boat, right? You're going to be way behind the curve on what we're doing because you got like Apple, right? Apple released the online version of Apple Music, so you don't need an app anymore. They built this thing and they shipped 42 web components inside of it, and they used Ember to stitch the whole thing together. Right? That's super cool. And then speaking of browsers, I don't know if you know this or not, but if you're using Mozilla today, that whole damn thing is built by. They ship the whole browser using web components. So it's like everybody's doing massive things on it. So if you think you can't build a little tiny website and people are shipping whole browsers, then you're not understanding what's going on here. So show me the code. Build a web component. So I don't want to hurt anybody here. That's a web component. That's so what I went down the line before, and I said there's three ways of building web components. There's writing all the hardcore JavaScript, which is painful and difficult. Writing a preprocessor like Salesforce or using Stencil, or your next best option, in my opinion, is using what the Polymer team has basically evolved to, which is using lit element and lit HTML. So the Microsoft project that I showed before is like a lot of Microsoft projects I'm seeing are using this lit element library. So what lit element is that it's the next evolution from Polymer. And it's super, super lightweight, and it continues to like basically in last year, the browsers went from the V0 spec of web components to V1. The coming of age of web components and browsers. When they did that to V1, that changed everything, and we did not have to ship so much stuff to the browser anymore, right? And so what we're doing here in the first line is that like the browser today, because of ES6, understands this, right? I don't have crazy stuff anymore. I mean, I can do very simple, straight to the point stuff, and I'm doing an import, and I'm basically looking for the lit element and the HTML libraries. And this is super poor performance because I'm always reaching out and grabbing a library and sucking it down. But nonetheless, this will give you an environment that you can start playing with, right? And have a dev environment where all those things are local with npm packages. Then you just point to your local npm package. You wouldn't do this, but nonetheless, I'm instantiating a class. I'm creating something called my element, which is extending off of lit element, right? This is a basic feature of ES6 JavaScript of being able to a previous constructor, aka class, and then extend on top of that, and then start building my own thing. So that's kind of important to keep in mind, because as I get deeper into this, a little bit more crazier stuff that you can do. So inside here, simple enough, I have a render function. And then you'll see return HTML in the little back. So is everybody here familiar with what template literals are? So template literals is a new JavaScript thing that came with ES6. You to basically write anything inside the little ticks, and then JavaScript knows how to render it appropriately, right? So template literal is really what it's doing. You're taking a template concept and you're exposing it to the JavaScript engine, and it knows how to take that and turn it into different permutations. This named template literal, which is basically attaching a function to the simple concept of a template literal, and that's what the HTML statement is. So what this is doing, what this is giving us, is that inside of those backticks, and when this is rendered through lit element to the browser, it produces real HTML. Crazy, right? This is not JSX. It's React created. This is legitimate HTML that the browser will consume and then expose in the browser into the actual DOM as real HTML. No virtual DOM or any of that kind of jazz happening. Okay? Then the next thing in there is slot. Now, what slot is, what I'll show in the next slide, is a way for you to basically put content between the HTML elements you just created. Okay. So here I'm doing a script, like I'm basically bringing in the JavaScript from the element that I created, right? But I have a type module, which is like an up-resing of the type of thing of the JavaScript that I'm bringing in. Okay. So once I do that, now the environment knows how to render the elements that I just invented. So I use my element open and close tags, just like you do with regular HTML, and I stick in the middle of it, and then I have hello world. Done. Right? You just invented an element, and the browser did not pre-rendered. It doesn't have to do server-side rendering. It doesn't have to do anything. You just ship that little bit of code directly to the browser, and the browser knows exactly what to do with it. So all those other previous barriers are gone. So that's uninspiring. So we're going to make this a little bit better. So here a little bit. Up in the top, you'll notice that now I bring in CSS from the lit element import. So getting down, static get styles. So what this is basically, this is a lit element construct, which is basically saying, give me my static styles component, right? And then it's the same thing as a named template literal. I'm using CSS now at this point. And now I just put in regular CSS. This is real CSS that is going to get output, right? And then not even changing any of the HTML that I had before, now I get a pretty hello world, right? So what's cool about that when you think about it is that if you made like this header component or whatever you want it to be, it's like, well, how do I use it? Just point to the import, just make sure you have the resource, and then use the HTML inside of your other HTML or JSX, and then it does what you want it to do. Taking this up a little bit more, so this gets kind of fun. This gets into theming with components. So I'll try to talk real loud so my microphone. Has ever, you know what the host CSS selector is? Raise your hands who knows what host is. Okay. So for those who don't know what host is like you guys are familiar with CSS variables. Okay. So then there's root, usually, where you do root brackets, and then so host is basically the same thing as root, but it's within. Okay. So what I can do here, which is kind of cool, is that I can do host, friends, and then inside of brackets, I can basically look for attributes. Right? You can do that with any regular CSS, right? You can do an attribute type selector, and then once that attribute is there, then the CSS. So, but in my component, I'm inventing an HTML element. I'm also inventing attributes, right? So in my CSS, when I'm pointing to host and I'm looking for that attribute, when that attribute is assigned to one of these elements, now I get an instant theming change, right? So now you have the power within the component to allow the user to start that component depending on how they want to use it, right? So, one thing I didn't kind of, okay, so what I'm going to point out here is in the component, how I create those attributes is right up here. Function to create properties, and then I'm returning the property with the type of the property is, be it either a boolean, a string, or a function. Three things are. So now that I've defined those attributes, I can start doing a lot more interesting things with this. So I have my defined attribute. Now I'm going to create a function called mood. Right? This is basically just a bunch of if statements, is what's happening here if you don't understand what this says. But basically, I'm saying is like, if the attribute happy is there, then I want you to. If the attribute sad is there, then today is a sad, sad day. Or if none of those things are there, then there's no mood. You're moodless. You're evolving. Original type CSS. I have my theming, but then I've also introduced something else here. Is now I'm also going to write the CSS. I don't need to have button class. I don't need to have anything. I can basically just say button, because the only time this button shows up is within the scope of. Okay. Everybody repping that? Then I want to come over here. I'm just kind of showing this again because nothing changes. Nothing changed as far as the HTML is concerned. So this is kind of a cool thing to kind of keep in mind, Because if you've already shipped a component that has an API that people are using, and you can that API, then you can continue to ship more features. They never have to go and change the HTML, but now they're starting to get more features, which are magical. Okay, mood button that's showing up, and then every time somebody clicks it, they get a custom message. Super ridiculous feature that nobody ever wants, but nonetheless, you kind of start a component. I just delivered something to an end user without them having to do nothing. Okay, that is super powerful within itself. So, but now let's break this up even a little bit more. So, the one thing I didn't like is that there's so much stuff happening here now. Right? I have my properties, I have my mood function, I'm styling my header, I have my theming. You know, everything's happening down here inside my template. There's a lot of concerns that are in one place, right? So how do I break that up? Next one. So what I can do, super simple to get it out of the way, is I'm going to create a. This one doesn't generate a component, right? And I kind of skipped over that in the last one. This line down here, custom element my element by using my element class, right? So that's how, like, when JavaScript reads it, it gets to the bottom and goes, all right, I know. Getting here, that line's not here, right? So all I'm looking for is lit element, HTML. So I'm just doing that. I'm pairing my property extends from lit element, and I'm defining my properties. Cool. So now my properties, I can import in. So now I have two components here. So I have my button component and my element component. If we start over here, I'm bringing in properties. Okay. So that now this component is aware of that one. And now my button extends my properties, not lit element. Right? Because lit element is happening. Okay. So I'm extending the properties thing. So now I just sucked in the properties GUI goodness into here. I have my mood function, and then now I have a simplified template that is just for the button. I have a button component. Okay. Ooh, wait. All right. So if I go over to my element, I need to bring in properties, and then I also need to bring in button, because I'm going to nest that inside of. So I come down here, my element extends properties again, just like that one. So I get those properties from the primary component. I have my style and then my theming stuff. Now what gets interesting down here is how my template works. This is a relatively complex scenario using slide. So whatever you put between the elements, that's what's going to get put there, right? But now what I'm also doing is I'm putting in my button. We have two attributes here. Is like if this dot happy is satisfied, right? If that sitting there, then then happy will show up. Right? What this question mark is doing is that it's a Boolean with an attribute. If this is true, show attribute. Okay, if it's false, then the attribute never appears. So this is kind of like one of those scenarios. It's like you don't want to have like happy, false, sad, true, sad, false, and all that kind of stuff. Is basically it's just like it's an on-off switch, which is really nice. So what goes between my element and then my button down here, what I have is a name slot. Okay. So what that allows me to do from the HTML point, engineers, new feature, but you do have to update a little bit. My element has hello world, and then I have a span slot equals button. Remember, a name button. So slot button, no mood, good mood, sad mood. So now I get hello world, no mood, good mood. See how that kind of went there? Is from like the one element, I can talk to a nested element and I can pass it information. This again is a simple example on how to use slot, but basically if you can put whatever you can put between two HTML elements, you can put into slot. Right? That is super powerful. Get your head wrapped around that. You can start creating components that are basically kind of like collectors of other small components, and you are infinite flexibility on how they can start to compose things, right? Because you allow them the ability to put other inside of a container that you're dictating on how that container works and how it composes the things inside of it, right? It just right here, right after this, you hit the hockey stick moment, and you're like, oh my god, the universe is infinite. I can do anything now. So this way of dealing with CSS, right? And everybody's kind of looking at this and going like, that's kind of crap. I don't want to write all my CSS inside of backticks. What about, right? Okay, fine. We can do that. So there is actually a tool that is called WC-SAS-render. And what that tool does is that you can do whatever you want with SAS and CSS outside of it. It'll create a CSS file. You can attack it with SAS render, and then it'll output a whatever name -css.js file. And it basically is using the same template stuff, right? So I'm importing HTML from that element, and I have the default HTML backtick, and I basically the template tool did all that for me. So when I come over here, I need to import my button styles, exterior file. When I did that, I gave it a variable name. And then down here inside of my HTML template, I'm just returning, this gets injected into there. And then it works. Right, so I've taken that CSS out of the component, put it into ran it through a processor that gives me a slightly different templated version, brought it back into the thing, and so now I can use that whatever component I want to. Right? There's no duplication of everything. I can do it all day long. Yeah.
Can you go backwards?
Oh, totally.
So one more thing is discovered. Do it that way, then you look at your DOM, and every component you have
Yes.
style tag and a bunch of stuff.
Sure.
Right? So it looks a little bloated, to me a little hard to debug, or it's kind of like seems unnecessary. I don't want it to be sitting there in the DOM. So the way to go around it is with this library, you can actually change this template.
Sure.
Right here, you can replace it with a different template. So instead of saying HTML dash style tag, I say, I actually, from the lit element, I'm going to import CSS.
Oh, you mean like this? No, you can finish.
Keep going.
No, go ahead.
So you import CSS and have a CSS template literal here that has the same content, but then when you get it here, instead of putting it into a style tag, you put it into a get styles method. What it does, it creates, when browser supports it, constructible style sheets.
Constructible style sheets. Yeah. Problem with the tools that we have right in front of us. Okay. And you know, she brought up another great point is the future of constructible style sheets, because that really is that is a huge endeavor that everybody's pushing for right now, which then kind of breaks the chain. Because she's right. In the previous example, when you the CSS rendered inside of the HTML, you get a lot of CSS rendering, good or bad. I'm running with that version right now because the constructible style sheet thing was like hella pain to get that to work with legacy browsers. right? So just shoving inside of the HTML a handful of components within every page because we're totally testing out how we're building these things. We're totally testing performance. And one of the cool things is that like there is no performance change. What you do, you're going to load that CSS and you're going to load that HTML into the page. The weight of the constructor, the class for the component itself is so small it doesn't matter, right? It's not going to move the needle at all. Your big thing is going to happen is like how complicated do you make the component? How much feature and functionality does it have? And how many times does that thing get added to the page? So if anybody, though, has done Web Performance 101, what is the first thing that every No, well, there's that, but that's not what I'm looking for. It's like if you want your website to be faster on first load, how do you get it to be faster? You put all your CSS. You don't make it a call. So you are loading a ton of stuff, but it's in that first call. It's in that first call with the HTML, so it's instantly there, and the browser turns it on. Right? So you're not the needle doesn't move. So this is only the beginning, like I said. Let me say in closing is that growing acceptance in the enterprise community is happening. Right? This is not thing. There are tried and true tools out there and information. And if you have any question about like how to get this to work with legacy browsers, you have just a question in general on how to do things, there is so much information out there right now. The one thing I will say is that if you are just starting to get into web components now and you're looking for information, Overflow is a really poor resource because nobody talks about it over there yet. And if you find any article that is more than a year old, ignore it. Because everything. So going into 2020, this was one of the major motivations on why Justin created the meetup in San Francisco, and this is why I'm trying to get people to, same thing with Yana is that like the information starts today, right? The blogs start getting because all of the information from yesterday is woefully outdated, and if you see anybody make a reference to things that are it's like paper components or iron components or all that Google and Polymer came up with, just like set it on fire and pretend you never saw it because none of those patterns work with the stuff we're dealing with today. So the cool thing is if you're an engineer and lit HTML, like I challenged one of my engineers to do this. I was like, he gets on the train in SeaTac and he rides that all the way up to Capitol Hill. I was like, you can read both APIs before you get home. And he sure as hell did. They're that small. Right? This is not like learning React. This is so straight to the point because if you're an engineer who's been doing 9% of the stuff that's happening, you already know how to do. This is just a construction of how it's being done. Works in all browsers. Hell yeah, it does now. Right? Legacy browsers, we'll deal with them as we go by. But I mean, I think IE 11 is easily supportable. IE 10 and 9 and 8, you start running into it, but it can be done. It just kind of depends what your cost versus value is. The performance, like I said, is super awesome. You ship it to the browser, it just works. Solves the CSS problem without a doubt. You can write a component, and like I showed before, you write all your styles around a button, and then you have an HTML button come right after that. They don't know each other exists. Awesome in that regard. Plays well with others. We at Alaska, we have run basically development, and we built small things using the components that we had, and it all just works. I mean, there's small bumps in the road that we run into, but I mean, if you're an engineer and you to a small road bump, then you should really have a different profession. Fact. Accessibility. This is important, right? One of the things that I talk about this whole time is accessibility is a big problem that people need to solve, right? Alaska Airlines is a government. We're a privately owned company, but we are a government agency, so we are mandated that our stuff has to be accessible, and we're not doing a very good job of it right now. moving forward with building out the web components for the design system is I'm baking accessibility into the component. There's an accessibility API that when an engineer can, they have to hook it up the right way and they will get instant accessibility. And so we don't have to go through and check everybody's code and follow people around and go through massive training sessions. We can help them be delivering something that they consume that will work. Versionable, deployable, maintainable. My God, I have like the small set of components that are already built for Elastic. So many changes, and it's been not even remotely a headache for me to version and maintain these things because it is a small subset your head wrapped around, and I add features or remove features from, and I can communicate that easily. Right? So none of the engineers that are using any of my stuff are like, dude, you totally screwed, except for the time we did a major release accidentally, and we won't talk about that. But nonetheless, that was human error, right? We did the release wrong. That falls into the regular scope of releases, major, minor fix or patch. Every consuming engineer understands what's happening there, and the component software doesn't throw anybody for a loop. So that's me. That's where I work. That's all I do. And this is where we are. So I did put in the thing, and I am willing to do a post showing basically building from scratch all the examples that I have in here. It's all on the GitHub repo. I will help anybody do that if they want to do that. If you don't want to stay for that, prerogative as well. But the next 15 minutes or so, thought I'd let everybody chill, decide what you want to do, and then we'll pick it up from there.